When we think of galaxies, we often imagine stillness, elegant spirals quietly floating in the darkness, their stars moving in graceful, orderly paths. But the truth is far more dramatic. In the vast depths of space, galaxies are anything but motionless. They move, they twist, they tumble, and sometimes they crash. Galaxies are not isolated islands. They are parts of vast cosmic webs, drawn together by the invisible hand of gravity. Over billions of years, their motions bring them into each other's paths, slowly, inexorably, and violently. These are the grandest collisions in the universe, cosmic events that span hundreds of thousands of light years, involve trillions of stars, and reshape entire galaxies. They are beautiful, violent, and awe-inspiring. They are not mere accidents. They are part of how the universe evolves. Welcome to the universe's grandest demolition derby. A galactic collision occurs when two or more galaxies are drawn together by gravity and eventually merge. It's not a sudden impact like a car crash on Earth. Instead, it's a slow-motion ballet that can take hundreds of millions to billions of years to play out. These collisions don't just involve two star systems brushing past each other. They involve entire galaxies, each one made up of hundreds of billions of stars, massive black holes, dense clouds of gas and dust, and mysterious dark matter halos, coming together in a gravitational embrace. And while that sounds catastrophic, here's something surprising. Most of the stars inside those galaxies don't actually collide. That's because galaxies are mostly empty space. The distances between stars are so vast that during a collision, they typically just pass by one another. What does collide, however, is the gas, the dust, and the dark matter that shapes a galaxy's form and future. The result? Chaos, transformation, and sometimes the birth of entirely new galaxies. This isn't just something that happens far away. It's something that will happen to us. Right now, our Milky Way galaxy is on a slow but inevitable collision course with the neighboring Andromeda galaxy, our largest galactic neighbor in the local group. The two are racing toward each other at about 110 kilometers per second. That's roughly 250,000 miles per hour. Don't panic. The collision won't happen for another 4 billion years. But when it does, it will change everything. The two spirals will begin to interact gravitationally, pulling on each other's arms, distorting their shapes, flinging stars into long arcs, and compressing gas clouds that will trigger furious bursts of star formation, what astronomers call a starburst event. Ultimately, Milky Way and Andromeda will merge to form a completely new galaxy, likely an elliptical one, larger and more massive than either of its progenitors. Scientists have even given it a name, Milkdromeda. From Earth, if Earth still exists, the night sky will light up with new stars, strange structures, and eventually, a new galactic identity. So, what really happens during these massive galactic encounters? At first, it's subtle. Two galaxies approach each other, their outer halos of dark matter already interacting. Tidal forces stretch and twist their spiral arms. Long streams of stars are pulled from the edges, creating tidal tails, gorgeous, shimmering trails of light that stretch for hundreds of thousands of light years. As the galaxies pass through one another, their gas clouds collide and compress. This triggers massive waves of star formation, clusters of new stars forming at rates far above normal. Some of these stars will live fast and die young, exploding as supernovae and seeding the galaxy with heavy elements. Then comes the core interaction. The central supermassive black holes of both galaxies are pulled toward each other. Over millions of years, they spiral closer, surrounded by swirling disks of gas. Eventually, they will merge, releasing gravitational waves that ripple across the universe, a final echo of the cosmic union. By the end of this process, the galaxies are no longer what they once were. Their structures are altered, their orbits changed, their identities merged. Not all galactic collisions are the same. In fact, there's an entire spectrum of encounters. When a large galaxy swallows a smaller one, it's called a minor merger. These are common, and over time, they help galaxies grow. Our Milky Way has absorbed many smaller dwarf galaxies over the past few billion years, and remnants of those mergers still orbit our galaxy as streams of stars. But when two galaxies of similar size meet, that's a major merger. These are rarer and far more dramatic. Major mergers can completely transform galaxies, turning elegant spirals into chaotic ellipticals, destroying delicate disks, and redistributing stars in new, random orbits. Sometimes, collisions result in ring galaxies, beautiful systems where the collision sends a ripple outward, forming a ring of stars and gas. Other times, galaxies develop long, tail-like appendages that arc and wrap around their hosts like ribbons. Each collision is unique, shaped by the mass, speed, angle, and composition of the galaxies involved. Galactic collisions aren't just spectacles, they are engines of cosmic evolution. They build new structures, ignite fresh starbirth, and recycle the raw materials of the universe. The heavy elements forged in stars and supernovae are redistributed across galaxies, seeding future generations of stars and planets. Some of the stars born in these events will go on to form planetary systems, possibly even ones like our own. In fact, the Sun likely formed in the aftermath of a galactic collision that occurred long before our solar system existed. The material that makes up our bodies, our world, and our history was shaped in the fiery aftermath of ancient galactic encounters. Without collisions, galaxies would evolve more slowly. They would remain isolated, cold, and relatively unchanged. But the universe is not a quiet place. It's dynamic, active, and deeply interconnected. Collisions are part of that story. They are the sculptors of the cosmos. Behind the scenes of these epic events is an invisible actor, dark matter. Though we cannot see it, dark matter makes up most of a galaxy's mass, and it plays a crucial role in how galaxies collide and merge. The dark matter halos of galaxies extend far beyond their visible edges, acting like invisible gravitational fields that shape the encounter long before the stars or gas ever touch. Astronomers use supercomputer simulations to model these interactions. They can input the mass, velocity, and dark matter distribution of two galaxies and simulate what happens over billions of years. These simulations produce astonishingly realistic images: spirals colliding, stars flying, black holes merging. What's more, many of the most famous astronomical photos, from the Hubble Space Telescope to modern observatories, have captured actual galaxies in the midst of collision. We've seen galaxies being torn apart, twisted into bizarre shapes, and born anew. The sky is full of cosmic dramas, frozen in mid-act. The universe is not static. It's not quiet. It's not still. It is constantly evolving. Galaxies crashing, stars being born, black holes merging. And every one of these events leaves behind something new, something different, something beautiful. Galactic collisions are not accidents. They are part of a cosmic dance choreographed by gravity, a dance that spans billions of years and reshapes the structure of the universe itself. One day, our own galaxy will join that dance. And though no human will be around to witness it, we know now what to expect. We've seen the simulations. We've watched the stars. We've read the sky. In this great demolition derby of the cosmos, destruction is not the end. It is a new beginning.